So the properties are to do the 7.11 exercise is the first property is 0 to a f of x dx can be written as 0 to a f of t dt. Next is 0 to a f of x dx can be written as 0 to a f of a minus x into dx. Okay, then next property, it's like 0 plus a is a, so a minus x. So if it's a to b f of x dx, it can be written as a to b f of a plus b minus x into dx, because 0 plus a is a, so a minus x, a plus b minus x. Next property, 0 to 2a f of x dx can be written as 2 times 0 to a f of x dx, provided f of 2a minus x is the same as f of x. If f of 2a minus x, f of 2a minus x turned out to be minus of f of x, if f of 2a minus x turns out to be minus of f of x, then the answer itself will be 0. Okay, next property. Yeah, I've elaborated so much in the class about these properties. People who have missed the class, I don't know what to do, but I hope you mug up the property. Then 0 to 2a f of x dx. Then next is minus a to a f of x dx can be written as 2 times 0 to a f of x dx. So these are the properties that you have learnt, provided f of minus x is equal to f of x. If f of minus x turns out to be minus of f of x, then the answer itself is equal to 0. These are all the properties, and I have explained this property how it works in the class. Okay, so then the basic sum, the first sum that you need to know by heart very clearly is 0 to pi by 2 log of sin x, in which we'll apply the properties, almost 3 properties will apply. So if you apply 0 to a f of x dx can be written as 0 to a f of a minus x into dx. If you do that here, it will be log of sin pi by 2 minus x, which will be 0 to pi by 2 log of cos x. Moment I get that, I'll assume this as I and this as I, and I'll add it, and I get 2y is equal to 2 logarithm. When I get, I'll add it. So log of sin x into cos x, log a plus log b is log a into b. So log sin x into cos x, which itself is log of sin 2x by 2, which is log of sin 2x minus log 2. So log of sin 2x minus log 2 into dx and a dx with a 0 to pi by 2 and a 0 to pi by 2. So 2i is equal to, this is minus log 2 can be taken out, and integration of it will become 1 dx, which is just x on using upper limit minus lower limit, it's minus log 2 into pi by 2. Whereas this itself is a separate question which came for board exam. What is the question? This came for board exam, 0 to pi by 2 log of sin 2x dx, in which you have to assume 2x as t, 2 into dx as dt. So if the limits also will change when you're going to convert this as log of sin t into dt by 2, because dx is dt by 2. The limits will change when x is 0, t is 0. When x is pi by 2, t is pi, it becomes like this. Now this is 0 to pi, which resembles the property 0 to a 2a f of x dx can be written as 2 times 0 to a f of x dx, provided f of 2a minus x is the same as f of x. Look at this, and this is the function, and log of pi minus sin of pi minus t is log of sin t. The function is not changing. So therefore you can write it as 2 times 0 to pi by 2. So you can write it as this one as 1/2 of 2 times 0 to pi by 2 log of sin t dt. So the 2 and 2 get cancelled. I can just replace t as x by the first property. You see here the first property is to just, if the limits are the same, you can replace x as t. So then therefore it will become log of sin x into dx 0 to, this itself is a question I. So I tried to solve this question here, taking it separate, and I got it as I. So take it left side, I is equal to minus log 2 into pi by 2. Therefore I is equal to minus log 2 into pi by 2, and you should know the sum by heart. Okay. Next is the next question that I would like to teach you is 0 to pi log of 1 plus cos x. There's a specific order in which you have to go. This is the order. This is 16th sum in the textbook in 7.11. This is an example sum. First sum is an example sum. Example 36. So next, if you're going to apply property 0 to pi log of 1 plus cos pi minus x, the property 0 to a f of x dx can be written as 0 to a f of a minus x dx. So it is, if I do that, it will become log of 1 minus cos x, because pi minus x is second quadrant, it will become log of 1 minus cos x. And in definite, I won't write 1 plus cos x is 2, cos square x by 2, nothing like that, okay, because they are going to assume this as I, assume this as I, and add these two, because log a plus log b is log a into b, which is log of 1 plus cos x into 1 minus cos x, which is log of 1 minus cos square x, which is log of sin square x, which is log 2 log sin x. Okay, therefore it will become 2 into 0 to pi log of sin x into dx. Now if you see 0 to pi, and you know that it's comparable with the property 0 to 2a f of x dx can be written as 2 times 0 to a f of x dx, provided f of 2a minus x is the same as f of x. You know that sin pi minus x is going to remain as sin x, yeah. So log of sin pi minus x will be remaining as log of sin x. The 2 and 2 here gets cancelled. So I itself 2 times 0 to pi by 2 log of sin x dx. Okay, now this itself is a previous question, if you remember, whose answer is minus pi by 2 log 2. Minus pi by 2 with already existing 2, 2 and 2 gets cancelled, so answer is minus log 2. The advantage is you know the sum how to do. 0 to pi by, you have to repeat the same sum, 0 to, if I is equal to 0 to pi by 2 log sin x dx, it will become 0 to pi by 2 log cos x dx using this property, and then adding these two, it's log of sin 2x by 2, which is log of sin 2x minus log 2, integrated, taken out, and you get a pi by 2. This itself is a board exam question, take it separately, 2x st, 2 into dx is equal to dt, dx equal to dt by 2, substituting there, you get limits will change. So that's about it, okay. So next question, you have to memorize in this order, okay. So the third question that I would like you to memorize is 0 to pi by 4. When I say pi by 4, I know the question is about tan x, okay, and you have a log of 1 plus tan x dx. So when you have a log of 1 plus tan x into dx, and it will become 0 to pi by 4 log of 1 plus tan pi by 4 minus x dx. In this sum, I don't think I need an I, because I can solve it. I am not going to add anything because I am going to use tan pi by 4 minus x. Each sum has a different approach. Log of 1 plus 1 minus tan x by 1 plus tan x. All this I would have taken at least 3 times in the class. So people who are not attending classes, I can't be answerable because it's very hard for me to take everything again. And there are techniques that I have taught to remember. And all those people who have taken leave would not be able to do it. So then, so it's 1 plus tan x. So when you take LCM, it's 1 plus tan x plus 1 minus tan x. The tan x comes log 2 by 1 plus tan x, which is log 2 minus of log of 1 plus tan x into dx here also, dx here also. Can you see? This itself is I. Therefore, now I decided I am going to assume the left hand side as I. So when I bring this I to left hand side, I get 2i is equal to, here log 2 can be taken out, integration of 1 dx, it will become just x, integrated from 0 to pi by 4 because that is a limit, and 2i is equal to log 2 into pi by 4, upper limit minus lower limit is pi by 4 minus 0, which is just pi by 4, and so I is equal to log 2 into pi by 8. Or pi by 8, you can't cancel the log 2 letter 2 and this 8 and all, okay. So the answer is minus pi by 8 into log 2, okay. So that's the third sum that you need to memorize. You should know it like really clear, okay. The next sum that I am teaching you is the 12th sum in that exercise, which is 0 to pi x sin x by 1 plus sin x into dx. Whenever you have an x here, whatever be the limit, I will write just do pi minus x into sin x, because sin of pi minus x is sin x. By 1 plus sin of pi minus x is also sin x. So if you see, if I apply the property 0 to a f of x dx, can be written as 0 to a f of a minus x dx. All these things does not change, only pi minus x. Now I am going to assume this as I and this as I. I am going to add them, I get 2i. The x sin x by 1 plus sin x will get cancelled. I will only have a pi sin x by 1 plus sin x to be integrated. Pi sin x. Oh yeah, because it will come in and I will have a pi sin x by 1 plus sin x. Sorry, it will be 0. I think I made a mistake there when I was doing this sum. Now I hope you are clear, because pi into sin x by 1 plus sin x. Now if you see, if you apply property which is 0 to 2a f of x dx, which will become 0 to 2 times 0 to a f of x dx, provided f of 2a minus x is the same as f of x. In sin, pi minus x is going to remain sin x. So the function remains unchanged. So I can write it as 2 times 0 to pi by 2 sin x by 1 plus sin x into dx. The 2 and 2 get cancelled. So I itself is pi into a sin x by 1 plus sin x. So then what can I do? I mean, I am not supposed to rationalize, because I will get, as soon as I see this, no, so I will think of writing a sin x plus 1 minus 1 by a 1 plus sin x dx, so that I can split it up. Split this up, LCM. Pi into 1 plus sin x by 1 plus sin x is 1 dx, with the pi is constant throughout common, minus 1 by 1 plus sin x dx, 0 to pi by 2, and a 0 to pi by 2 here also. So when I do this, I is equal to pi into integration of 1 dx is x minus x 0 to pi by 2, of course, upper limit minus lower limit. This itself is 1 by 1 plus sin x. Never ever rationalize in definite integral. So applying the property again, with first property 0 to a f of x dx can be written as 0 to a f of a minus x dx. It will become 1 plus cos x dx. The advantage is 1 plus cos x itself is 2 cos square x by 2. So it's pi into upper limit minus lower limit here is pi by 2 minus this is integration of 1 by 2 cos square x by 2 into dx, 0 to pi by 2. So it's pi into pi by 2 minus 1 by 2 into integration of secant square x by 2, which is tan x by 2 by 1 by 2. This and this get cancelled. You still have to apply 0 to pi by 2 as the limit. In x by 2 is there. When you apply pi by 2 there in the place of x, it will become pi by 4. So tan pi by 4 is anyway 1. So you can ignore that, and you get a pi into pi by 2, which is pi square by 2 is the answer for this sum. Okay, which is the 12th sum in the textbook with the 7.11 exercise. 1 second. 7.11, 12th sum. 12th sum answer is just pi. Okay, answer is just pi, but I am getting a pi square by 2. Okay, let's see, it's x sin x by 1 plus sin x, pi minus x into sin x, yeah, and when you take it in, x by 1 plus sin x is getting cancelled with, but pi sin x by 1 plus sin x is still remaining. So pi into sin x by 1 plus sin x. The moment I see the denominator, I can write it as, I can apply the property 2 times 0 to pi by 2, and then I did plus 1 minus 1 and split it up as sin x plus 1 by sin x plus 1 dx minus 1 by 1 plus sin x. This is just x, integration of 1 dx is x, upper limit minus lower limit is pi by 2, so it will become, pi is already outside also. And this, when I apply the first property 1 plus cos x and 2 cos square x by 2 secant square x by 2 by 1 by 2, so the 1 by 2 and 1 by 2 get cancelled, upper limit minus lower limit is tan pi by 4 minus 0. So I get a pi in, oh, so this, there was a 2i right on the left side, yeah, that also has been cancelled. So why am I not getting the answer? 7.11, no, there is no x sin x, I copied the question wrongly, okay. So if the question was x sin x, this is the way we would do, yeah. But if the question was, actual question is actually 0 to pi x by 1 plus sin x, there is no x sin x, okay, that is actually a board exam question. So you can, might as well learn it, okay. So in this, if you use the property, it will become pi minus x by 1 plus sin x dx. This is also I, this is also I. So this is not the 12th sum. Basically, I've done some board exam sum which came like this, but you understood how to do it. So in this, if I apply the property f of x is equal to 0 to a f of x dx can be written as 0 to a f of a minus x dx. So then it will become pi minus x, and if I add this as I and I, you get x and x get cancelled, pi into 1 by 1 plus sin x dx as 0 to pi. And as soon as you see this, it's like 0 to 2a f of x dx, 0 to 2a f of x dx can be written as 2 times 0 to a f of x dx, provided f of 2a minus x is the same as f of x. Just see, sin pi minus x is sin x, not going to change, so you can write it as 2 times 0 to pi by 2, 1 by 1 plus sin x. 2 and 2 get cancelled. So I never rationalize, because you will get tan infinity. Never rationalize, only in indefinite will you can rationalize. You can apply the property f 0 to a f of x dx can be 0 to a f of a minus x dx, when it will become 1 by 1 plus cos x dx. The advantage of it is 1 plus cos x is 2 cos square x by 2. And this itself is I can pi by 2 into integration of secant square x by 2, which is tan x by 2 by 1 by 2. The 2 and 2 get cancelled. The limits is 0 to pi by 2, and in the place of x if you substitute pi by 2, this will become tan pi by 4, which is 1. So answer itself is pi. Okay, so that's this sum. Next, okay, so then make sure that you're doing the right sums. After this, I taught you the order in which I went is the 15th sum. 15th sum was 0 to pi by 2 as sin x minus cos x by, I think I did the 10th sum next. The order in which I taught you 0 to pi by 2, 2 log sin x minus log of sin 2x into dx, which will be log of sin square x by sin 2x, which is 2 sin x cos x. The sin 2x can be written as 2 sin x cos x. The sin and power get cancelled. The question is log of tan x by 2. It becomes like this, which is log tan x minus log 2, which is itself becoming log tan x minus log 2, 0 to pi by 2, and a dx here and a dx here with a 0 to pi by 2. You have to treat this as a separate question itself, because this itself is a board exam. This can be solved because minus log 2 into integration 1 dx is x, 0 to pi by 2. So it's minus log 2 into pi by 2. This itself is a board exam question. If you try to solve it, log of tan x into dx, if you apply the property 0 to a f of x dx is 0 to a f of a minus x dx can be written like this. So this is going to call it as I, and if you apply tan, this was 0 to pi by 2, right? If you apply pi by 2 minus x, it will become cot x, log of cot x into dx, 0 to pi by 2. If you add this equation and this equation, you will get 2i is equal to log of tan x into cot x, because log addition, log a plus log b is log a into b, 0 to pi by 2. Tan x into cot x is tan x into 1 by tan x, so log 1, and log 1 itself is 0. Therefore, this entire answer is 0. This itself is a 1 mark board exam question. So, answer for this sum is minus pi by 2 log 2. So, then next sum that I taught you was, I think I did the 15th sum, which was 0 to pi by 2 sin x minus cos x by a 1 plus sin x into cos x dx. So, in this, if I think I apply the property which is 0 to a f of x dx can be written as 0 to a f of a minus x dx. So, if you put sin pi by 2 minus x will be cos x, cos pi by 2 minus x will be sin x, by 1 plus sin pi by 2 minus x is cos x, and cos pi by 2 minus x is sin x, minus sin x, is it? Cos pi by 2 minus pi by 8 is only sin x, yes, first quadrant, so correct. So, this is also I, this is also I. Then you do 2i. If you see, the cos x and the cos x will get cancelled, sin x and sin x, numerator itself is getting cancelled, so I itself is 0 if you add them, yeah. So, that is a 15th sum. The next sum that I taught you was, I think I taught you the 14th sum, which was 0 to 2 pi cos to the power 5x dx. So, when you see 0 to 2 pi, it's 0 to 2a f of x dx can be written as 2 times 0 to a f of x dx. So you can write this is provided f of 2a minus x is the same as f of x, and cos to the power phi of 2 pi minus x is the fourth quadrant is cos to the power phi x. All school taught your children cos is positive. So then since the function remains unchanged, you can write 2 times 0 to pi cos to the power 5x dx. Now again I have to use the same property, ditto same property, and if I use cos of pi minus x, now it is coming the second quadrant which is minus cos x, the power is odd. So it is going to be negative, so the answer itself is 0 because f of 2a minus x is now turning out to be minus f of x, so answer will be 0. So that completes the 14th sum. So next is let us look at sums from the beginning. The first sum is 0 to pi by 2 cos square x dx. If you apply the property, f of x dx can be written as 0 to a f of x dx can be 0 to a f of a minus x dx. I am going to use that property. It is going to become sin square x dx. So cos pi by 2 minus x is sin x, so sin square x dx. So I am going to call this as I and this also as I. And if I add these two, I will get integration of 0 to pi by 2 sin square x plus cos square x, this is 1 dx. And 2i is equal to integration of 1 dx is x 0 to pi by 2. And 2i is equal to upper limit minus lower limit is pi by 2 minus 0, which is pi by 2, I is equal to pi by 4. So let us go to second sum. 0 to pi by 2, a root sin x by a root sin x plus a root cos x into dx. If I am going to apply the same property 0 to a f of x dx equals to 0 to a f of a minus x dx, you have to write the property 0 to a f of x dx can be written as 0 to a f of a minus x dx. So this will become cos x because sin pi by 2 minus x cos x, this will become cos x and this will become sin x and a dx. Denominator is anyway the same because it is addition. So they call this as I and call this as I and add it. Okay, you will get a root of sin x plus cos x by root of sin x plus cos x, which will get cancelled root of 1 dx 0 to pi by 2. So 2i is equal to integration of 1 dx is x, upper limit minus lower limit is pi by 2, I is equal to pi by 4 is the answer for this sum. So the third question, integration of 0 to pi by 2, okay, sin to the power 3 by 2x by a sin to the power 3 by 2x plus a cos to the power 3 by 2x into dx. As using the same property 0 to a f of x dx can be written as 0 to a f of a minus x dx. So this will become cos to the power 3 by 2x by a cos to the power 3 by 2x plus a sin to the power 3 by 2x, does not matter, the denominator remains unchanged, so you can add it, call it as I and call it as I and add the first two equations 0 to pi by 2 to become sin to the power 3 by 2x plus cos to the power 3 by 2x by cos to the power 3 by 2x plus sin to the power 3 by 2x, which is just the same, which is integration of 1 dx, which will be just becoming x on integration. Upper limit minus lower limit is pi by 2 minus 0, which is just pi by 2. So answer is I is equal to pi by 4 again. So let us go to fourth question. Integration of cos to the power 5x dx by a cos sin to the power by cos to the power 5x dx by a sin to the power 5x plus a cos to the power 5x into dx 0 to pi by 2. So then this is I am going to use the property 0 to a f of x dx can be written as 0 to a f of a minus x dx, which is going to become sin to the power 5x by cos to the power 5x plus sin to the power 5x into dx. Call this as I, call this as I, the limits is not going to change. Going to add them both, 2i is equal to sin to the power 5x plus cos to the power 5x by sin to the power 5x plus cos to the power 5x, which is just 1 dx, integration of 1 dx is just going to become x, upper limit minus lower limit is pi by 2, I is equal to pi by 4, same answer. So similarly let's move on to the seventh sum. Seventh sum is integration of 0 to 1 x into 1 minus x the whole to the power n into dx. So applying the property 0 to a f of x dx can be written as 0 to a f of a minus x dx. That's the first step I do in every sum literally. So it will become 1 minus x into x to the power n. When you do that, instead of x, if you write 1 minus x and 1 minus x the whole to the power n, it will become x to the power n. Now you can bring it in. It will become x to the power n minus x to the power n plus 1 with a dx here and a dx here, integrate from 0 to 1, 0 to 1. This will become x to the power n plus 1 by n plus 1 minus x to the power n plus 2 by n plus 2, integrated from 0 to 1. So it's 1 by n plus 1 minus 1 by n plus 2. So LCM will be n plus 1 into n plus 2. So it will become n plus 2 minus of n plus 1, which will be n and n get cancelled, 1 by n plus 1 into n plus 2 is the answer for this sum. So let's do the ninth sum. In between sums I've already completed, so I'm skipping certain sums. I'm coming in a peculiar order. So 0 to 2 x into root of 2 minus x into dx. So as soon as you see I can't bring it in, so I'm going to apply the property 0 to a f of x dx can be written as 0 to a f of a minus x into dx. So if you put that, it will become 2 minus x into 2 minus x, which will be 2 and 2 get cancelled, root of x into dx. Now this can be brought in. So when you bring that in, it will be 2 root x minus integration of x to the power 3 by 2 into dx. Take the 2 out, is integrate x to the power 3 by 2 by 3 by 2 minus this is x to the power 3 by 2 plus 1, which will be 5 by 2 by 5 by 2. That's all. So when this 2 goes up, it's 4 by 3 into x to the power 3 by 2. When this 2 goes up, it's 2 by 5 into x to the power 5 by 2 with a minus sign. It's got an upper limit and low 0 to 2, and this also 0 to 2. On substituting the upper limit, it will be 2 to the power 3 by 2 because x is 2 minus 0 to the power, that you can ignore, minus 2 by 5 into 2 to the power 5 by 2 minus 0 to the power 5 by 2 you can ignore. So this itself is like 2 to the power 1 by 2 the whole to the power 3, which is root 2 the whole to the power 3. Root 2 the whole to the power 3 is 2 root 2. So 8 root 2 by 3 minus this itself is root 2 the whole to the power 5, 4 root 2, which is 8 root 2 by 5. So if you take LCM is 15, this is multiplied by 5 and this is 3, 40 root 2 minus 24 root 2, which will be 16 root 2 by 15 is the answer. So please check the book back answer though. What is this? It's 9th sum. Let me check that out. 9th sum, 7.11, 9th sum. 7.11. Ninth sum, 16 root, yeah, by 15, correct. That's the 9th sum. After this, I think I did the 17th sum. It was root x by root of x plus root of a minus x into dx, 0 to a. On applying the property 0 to a f of x dx can be written as 0 to a f of a minus x dx, root of a minus x by root of a minus x plus root x. Denominator does not change, so you can add this and add this. And so it will be root x plus root of a minus x by root x plus root of a minus x. So it will be 2i is equal to integration of 1 dx, which is just x. On applying upper limit minus lower limit, it's a minus 0, which is just a, and 2i is equal to a, I is equal to a by 2 is the final answer. So let's go to 80. Let's go to next sum. I started using minus e to a, those properties. Okay, so that's the sums that I taught today. So let's say there's this sum, 13th sum. It's minus pi by 2 to pi by 2 sine to the power 7x dx. So it's like minus a to a f of x dx. You can write it as 2 times 0 to a f of x dx, provided f of minus x is the same as f of x. And sine to the power 7 of minus x is minus of sine to the power 7x. Even it's an odd power, so negative is remaining negative. And so if you put negative x, it's becoming negative. Function itself is becoming negative. So suppose f of minus x itself is minus of f of x, the answer itself is 0. Remember the property that I taught you, go back. So this question, the answer itself is 0, that's all. So let's go to sum number 11, minus pi by 2 to pi by 2 sine to the power 2x, sine square x, even power. So if I put f of minus x, it will be f of x, no problem. Because sine square of minus x will be sine square x only, the function remains unchanged. So you can write as 2 times 0 to pi by 2 sine square x dx, because the property is if minus a to a f of x dx is there, you can write as 2 times 0 to a f of x dx, provided f of minus x turns out to be f of x. Yes, in this sum it is. So this itself is a separate sum, board exam sum, where 0 to pi by 2 sine square x dx, if I use the property f of 0 to a f of x dx, 0 to a f of a minus x, it will become cos square x dx. This is also I and this is also I, and 2I is sin square x plus cos square x, which is 1 dx, which is 1 dx, and so it's x on integrating, so pi by 2. So I is equal to pi by 4. You already know this answer is pi by 4. Substituting 2 into pi by 4 here, you get a pi by 2, and that is your answer, pi by 2. So it's such a sum, very important. These properties are very important. Let's go to modulus sums, such as let me do the fifth sum. Is modulus of x plus 2 into dx. Integrate from -5 to 5. Looking at this, I won't consider modulus sum. I have different approach, okay, where I'll take what is this interval. It's -2 is the interval. I'll mark the lower limit -5 here. I'll mark the upper limit +5 here. You know, the function itself, less than -2, it will become -x minus 2, and greater than -2, it will become x plus 2. So I'll do the sum as -5 to -2. Within this bracket, it's -x minus 2 into dx, and plus a -2 to 5 x plus 2 into dx. So on integrating, this will become -x square by 2 minus 2x, -5 to -2, plus this will become x square by 2 plus 2x on integrating as -2 to 5. So you have to do an upper limit minus lower limit, an upper limit minus lower limit with a plus. So when you substitute -2 here, 2 2s are 4, in the place of x, x square is 4, minus 4 by 2 plus 4, upper limit. Lower limit is -5, which is -25 by 2 plus 10, and I have to subtract the upper limit and the lower limit. And here if I put upper limit, this is 25 by 2 plus 10, substituting x as 5, minus lower limit 4 by 2 minus 2 minus 4, upper limit minus lower limit. I have to solve this first and this next. So this will be -2 plus 4, which is 2, minus this on solving will be -5 by 2, which will be +5 by 2, plus this will become 45 by 2. This itself is 2 minus 4, which is -2, so plus 2. So then if you see this and this is 4, and this is 50 by 2, which is 25, so answer is 29. So that's the way you should do this modulus sum. So let's take the next modulus sum, which is the sixth sum, which is 2 to 8 mod of x minus 5 into dx. The interval is just 5, the lower limit is 2, upper limit is 8. So it will be -x plus 5 and x minus 5. This will become 2 to 5 minus x plus 5 into dx, plus integration of 5 to 8 x minus 5 into dx. So it will, on integrating, minus x square by 2 plus 5x, plus this on integration x square by 2 minus 5x, upper limit minus lower limit, upper limit minus lower limit, and add those two answers. That's all, you get the final answer. Okay, try the sum. You have to get the book back answer. Okay, the next sum is 18th sum, 0 to 4 mod of x minus 1 into dx. The interval in this sum is 1 for this mod, and 0 is lower limit, 4 is upper limit, minus x plus 1 and x minus 1. So sum will change 0 to 1 minus x plus 1 into dx, plus integration of 1 to 4 x minus 1 into dx. Integrate this is minus x square by 2 plus x, integrate from 0 to 1, and this will become x square by 2 minus x integrated from 1 to 4, upper limit minus lower limit, upper limit minus lower limit, and add those two answers, you will get the answer. Make sure you are getting the book back answers. So now I will go to 19th question. This is a very important question. It's a peculiar question, very important. 0 to a f of x into g of x into dx. You have to prove that it's equal to 2 times 0 to a. It's not a property, it's just some prove that sum. It's given that f of x is equal to f of a minus x in the question, and g of x plus g of a minus x itself is 4. These two are given. You know, take this left hand side, okay, 0 to a, right, f of x is f of x only, but write g of x as g of a minus x, applying the property. The 0 to a f of x dx, but it is 0 to a f of a minus x dx. No, only this you are changing, you are not changing the next one. Okay, so because if you change also, it's going to be f of x, so it doesn't matter. So now instead of g of a minus x, you can write 4 minus g of x. So replace this. So 0 to a f of x into 4 minus g of x dx. Now bring it in. it will be 4 times f of x dx minus f of x into g of x into dx, 0 to a, 0 to a. Now, this itself is a question, I can call it as I, and this is also a question, I can call it as I on the left side, and taking this I to the left side, 2I is equal to, and I can, one second, hold on. So, taking this I to the left hand side and calling the left hand side as I, question as I, 2I is equal to 4 times 0 to a f of x dx. The 2 and 2 get cancelled, you got I, which is the question itself as 2 times f of x dx, which is the question itself as 2 times f of x dx, a peculiar sum, very very important question. Play it again and again and learn the sum. 20th question is minus pi by 2 to pi by 2, and x cube plus x cos x plus tan to the power 5x plus 1 into dx. If you see, this is like minus a to a f of x dx. You are checking if you can write it as 2 times 0 to a f of x dx, provided f of minus x is the same as f of x. But if you see an x cube, if you put f of minus x, it is becoming minus x cube, power is odd. So, the answer is 0, because f of minus x turns out to be minus of f of x, the answer itself is 0 for that part. Similarly, this is also tan to the power minus x is tan to the power 5 into minus, tan to the power 5 into minus x is minus tan to the power 5x. So, it's f of minus x is turning out to be minus f of x, so answer is 0. Cos of minus x is cos x, yeah, but this x is negative, because it will become minus x into cos x. So, it's f of minus x is turning out to be minus f of x here also, the answer is 0. So, this is becoming 0, this is becoming 0, this is becoming 0. The only question that is left is this. So, let us rearrange the question. Integration of minus pi by 2 to pi by 2, 1 dx, that is all is left. And integration of 1 dx is x minus pi by 2 to pi by 2, upper limit minus lower limit, pi by 2 plus pi by 2 is just pi. So, 21st question is 0 to pi by 2 log of 4 plus 3 sin x by a 4 plus 3 cos x. So, if you apply the property 0 to a f of x dx can be written as 0 to a f of a minus x dx, it will become log of 4 plus 3 cos x by 4 plus 3 sin x. The denominator is not the same, but this log sum, right? Whenever this log, I will always assume this is I, and I will add to I. Log a plus log b on the right side will become log a into b, which is 4 plus 3 sin x by a 4 plus 3 cos x into 4 plus 3 cos x by a 4 plus 3 sin x into dx, and this gets cancelled. You see, log 1 is always 0. So, the question answer itself becomes 0. This completes the entire 7.11 exercise, which is very very important. Okay, please thorough this so that we can do the examples of miscellaneous next.